Good day, everyone. I remain Engineer Shegun, and you're welcome back to Real Class. Today, we'll be talking about circular motion and simple harmonic motion. So let's dive first into circular motion. Just like I previously said, a body set to undergo circular motion when it's moving around a circular path. In circular motion, we are going to be talking about some quantities different from the ones we have known before. Every other quantity that we have been talking about, like velocity, acceleration, those were linear quantities. Because it is circular motion, angular will come into play. So we'll be having our angular quantities also. But I want to quickly add that there is a relationship between the angular quantity and the linear quantity. When I say quantity, I'm talking about things like velocity, I'm talking about things like acceleration, I'm talking about things like displacement. So there is angular displacement and there is also linear displacement. Hence, I said linear quantity and angular quantity. So what is this relationship between linear quantity and angular quantity? The relationship between linear quantity and angular quantity is that linear quantity is equal to angular quantity times radius. Linear quantity is equal to angular quantity times radius. This statement is true for velocity, for displacement, and for acceleration. Hence, I have this equation. In this equation, S here is our linear displacement or linear distance. Here you will see that linear distance is equal to angular displacement times the radius of the circular path. Here, this V here is linear velocity. Linear velocity is equal to angular velocity times the radius of the circular path. Here, this is acceleration or linear acceleration, which of course can be called tangential acceleration. And tangential acceleration is equals to angular acceleration times radius of the circular path. You do not need to memorize from here to here. You already know velocity. Just know that linear quantity is equal to angular quantity times radius. And that is how we got this. What about this and what about this? This may be looking strange to you because of the symbol I'm using. Remember, I told you that W theta is angular displacement, W is angular velocity, and alpha is angular acceleration. So there you go. This concept is actually very easy because we have already know that velocity is displacement over time. You already know that. Velocity is displacement over time. But now, you are seeing this symbol. This angular velocity, the only thing I have added to it is angular. So if I know that velocity is displacement over time, now I'll simply say angular velocity is angular displacement over time. It's what you already know. So this is not strange, it's easy. But angular velocity can also be given as 2 pi f, where f is frequency. This is angular acceleration. Acceleration basically is change in velocity over time. Change in velocity over time. But this is not angular acceleration. You just add angular to it. So this becomes change in angular velocity over time. That is how we got this. So that is it for this equation. Let's talk about this. What do I mean by AC here? AC is centripetal acceleration. What is centripetal acceleration? For a body moving in a circular path, as the body is moving in that circular path, there is an acceleration that is directed towards the center of the motion. And that's what we call centripetal acceleration, as the name implies, centripetal. This one is still linear acceleration, which is meters per second squared. Just like this A here, not the alpha, the A here is also meters per second squared. But both of them are not exactly the same. This is centripetal acceleration directed towards the center of the circular path. And this is tangential acceleration. From here, we have centripetal acceleration to be equal to v squared over r, where v is our velocity and r is the radius of the circular path. If there is acceleration, there will be force. We'll get to understand later on that force is a product of mass and acceleration. If force is a product of mass and acceleration, then it simply means that centripetal force is centripetal mass is equals to mass times centripetal acceleration. Centripetal force is the force that keeps a body moving in circular path. Just like centripetal acceleration is directed towards the center of the circular path, centripetal force is also directed towards the center of the circular path. And it keeps that body moving in that circular path. It prevents it from skidding. Centripetal force is mv squared over r. All I just did was to add mass. Remember I told you that centripetal acceleration is v squared over r, but centripetal force is mass times centripetal acceleration. So I added mass. This is also another expression for centripetal force because there are two expressions for centripetal acceleration. This is it and this is it. Now, there are some questions whereby they can relate centripetal force and frictional force. Why would they do that? Because I told you that centripetal force is the force that keeps the body moving in a circular path. And that centripetal force, depending on the type of circular motion, can be provided by several things. For a car moving in a circular route, what's provided the necessary centripetal force is the frictional force between the tire and the road. That's why the car can move in a circular path with a certain velocity and it will not skid. For the earth moving around the sun, what is providing the centripetal force is the gravitational force of attraction between the earth and the sun. If I were to take a bunch of key and tie it to a rope and I'm spinning that rope, what's going to keep that key moving in that circular path is the tension between the tension in the rope. So this area is where they can bring questions from, and they can relate, or they may want you to relate centripetal force with frictional force. So I just simply said that in those kind of cases, any question whereby they will be asking you, they will be telling you that the body is moving in a circular path, they will ask you for the mass, they will give you the mass, and they'll be asking you for things like coefficient of static friction. Note that you are going to equate centripetal force with frictional force. Remember we said centripetal force is mv squared over r. Frictional force is mu mg, where mu is our coefficient of static friction. Now from here, this is mass, the same mass here, and this mass will cancel out this mass. That is why I ended up having v squared over r is equal to mu g. So whenever they are asking you to find coefficient of static friction and it's a circular motion question, you can just make this mu subject of formula, and then you are good to go. You do not need to memorize this last part I just said. You can always remember that frictional force is equal to centripetal force. Now, there's one aspect that can also ask questions from, and that is banking of roads. Why do we bank roads? And what is banking of roads all about? A circular road, when we say the road is banked, it means that the road is tilted to the center. So there's a slope from the edge of the road to the center, so that the car can move around that road without skidding. The reason why you bank road is to increase frictional force between the tire and the road to prevent skidding. The next thing we are going to look at now are questions on circular motion. Still on circular motion. This is question number 1. And it goes like this. If an object moves in a circular path of radius of 0.7 meter, records a speed of 2 meters per second, what is the angular velocity? Now, in this question, I know that this speed that I've been mentioned, which of course I can consider as the velocity. Of course, speed and velocity are not exactly the same. One is scalar, the other is vector. I've said that before. Speed is a scalar quantity and velocity is a vector quantity. Now, so our V is 2 meters per second. So I will say V is equals to 2 meters per second. I know that this is V and not W because the unit of W, which is our angular speed, is radians per second. And the unit of the angular acceleration is radians per second squared. Here they are asking me to find the angular velocity. They specified it here. And if you check your options, you see the options are in rads per second, which means radians per second. So obviously, and of course, radius was given to us, which is 0.7 meters. I know that the equation to use is the relationship between V and W. And that relationship is that V is equals to WR. I'm looking for W. All I need to do is to make W subject of formula. If I do this, I'm going to have W is equals to V divided by R. So I would say W is equals to, we know what our V is, which is what? 2. And then we know what our R is, and our R is 0.7. And if I were to say 2, and if I were to say 2 divided by 0.7, I'm going to have 2.8. 2.857. This is approximately 3.0 radian per seconds. So then I'll say that my answer is option C, 3.0 rads per second. Now let's consider the next question. Still on circular motion. Now we are to consider question number 2. Question number 2 is from UTME 2011. And the question is, an object of mass 2 kilograms moves with a velocity of 10 meters per second squared round a circle of radius 4 meters. Calculate the centripetal force. Now we are being asked to find centripetal force. In this question, we're given the velocity, linear velocity, which is V. We're given the mass, M. We're given radius, R. So obviously, we are going to use this equation. Fc is equal to mv squared over R. This is the equation we are going to use to find our centripetal force. Now, from here, we can put in our parameters. Our mass is 2 kilograms, so I put 2 times. The velocity there is 10 meters per second squared, so I'll put 10 squared divided by the radius, which is 4, then 4 here. This is the same as saying 2 times 10 squared will give us 100. Of course, 10 squared is 10 times 10 divided by 4. From here, 2 times 100 will give us 200 divided by 4. If I divide 200 by 4, I should get 50 Newton. So the centripetal force is 50 Newton. So from this and everything I've talked about, in a question whereby they were asked to find the coefficient of static friction, you can always do that from that equation I gave you. And all of other questions that can come from here will just require you use the making some other parameters subject of formula from all the equations I've given you. You should also note that circular motion is the only type of motion whereby the body can have a constant speed and a uniform acceleration simultaneously. With this said, in our next class, we are going to look at simple harmonic motion.